Have you ever found yourself puzzled by how certain functions in R work? If you're diving into the Epi package and its spline functions, you're not alone. Today, we're going to unravel the mystery behind the ens function and its detrend argument. I totally get it. It can be really confusing when you expect one thing from a function, but it behaves differently. You're not the only one who has faced this challenge. Many users have similar questions about the Epi package. Let's set the stage. One user recently asked, how does the ns function in the Epi package handle the detrend argument? They expected it to project the basis onto the orthogonal complement of the column space, but the results were unexpected. Sound familiar? Let's explore this together. So what's going on here? When you set detrend to true, you might expect the output to align perfectly with the splines package. However, the matrices produced by Epi and splines are not the same, even though they share the same column space. Let's break this down. And stick around. By the end of this video, you'll have a clearer understanding of the differences and why they matter. Plus, I have a special insight that could enhance your R programming skills. To address the user's first question about whether the behavior observed with the Epi package is true in general, we can clarify that while the column spaces of the matrices produced by Epi, ns, and splines, ns, may be the same, the actual basis functions generated can differ. This is due to the different ways the two functions handle the detrending process. Now, regarding the second question about why the two functions produce different results, it's important to note that when the user sets detrend to true in Epi ns, the function uses a specific method to determine the derivatives. This involves passing NA values for the fixel argument, which affects how the spline basis is constructed. The user also mentioned a warning about the fixel argument being ignored. This indicates that the Epi package is designed to prioritize the detrending process over the fixel settings, which may lead to different spline behavior. Finally, to understand the mathematical reasoning behind these differences, the user might consider exploring the underlying linear algebra. The orthogonal complement of the column space of the const matrix is indeed used to ensure that the desired derivatives are zero at the boundaries, which is a key aspect of spline fitting. Fun fact, did you know that the concept of splines originated from the drafting tools used by engineers? Just like those tools, our spline functions help us create smooth curves from data points. Now let's look at the answers provided by other users. A user pointed out that the issue with fixed cell being set to NA was actually a bug that has since been fixed. They also mentioned that they reached out to the maintainer to suggest making the fix more consistent with the conditions, but overall they believe this issue can now be considered resolved. Here's a takeaway. Always check the documentation for functions like ns and ns. Understanding the underlying mechanics can save you a lot of confusion and help you write better code. And there you have it. Now you should have a better grasp of how the ns function works in the Epi package. Remember, diving deep into documentation can unlock new levels of understanding. If you found this video helpful, don't forget to subscribe for more insights.